right, Scott, I shared with the class your efforts to become the record holder in the distribution exercises, and as I told your mom, I will unofficially credit you with a 1 minute 55-second record. So Sophie is still the official record holder because it was done in class in my presence, where I could verify. She only did it 4 times, and I could verify that everything was indeed accurate, and without any chance of answers being edited prior to photos being sent and all that. But I'm pretty impressed that you took the time to record yourself doing the exercises. It was something to watch, for sure. I appreciate your competitiveness and desire to be the champion. So you are now an unofficial legend. But I'll write down your unofficial time. I'll put an asterisk next to it, like Barry Bonds and his 74 home runs with an asterisk next to it, because he was juicing at the time. And so you are unofficially the record holder. But anyway, pretty impressive. Got to hand it to you. Anyway, homework, page 199 in your textbooks. Homework, you did numbers 2 through 22, the even, on page 199. Let's take a look at those as we get started. Page 199. I was going to try to say it in Spanish and couldn't figure out how to say 100, so I don't even know how to say 99 for that matter. Anyway, number 2 from your homework, page 199, Joshua. What is that thing?
A third-degree trinomial.
Not on number 2, Lana.
Third-degree polynomial.
It is third degree, but it's just a general polynomial. There's 4 terms. Now, number 4 is a third-degree trinomial.
Yeah.
Now, it's not in descending order, right? The third-degree term is the middle one, okay? But the x descends at least. But it's a third-degree trinomial for number 4.
Third?
Okay, remember, each term you add up the exponents. But the polynomial just takes whatever degree the biggest term has. So on number 4, the first term is second degree, the second term is third degree, and the third term is first degree. So the polynomial gets whatever the biggest degree is. The biggest degree is 3, it's third degree. Just like on number 2, it's third degree because the biggest term is third degree. Does that make sense? Whereas on number 3, for instance, that's all one term. That's why you have to add them all together. Does that make sense? All right. No, it doesn't make sense. All right, number 6. When we add those together, Adam, what do we get?
Negative 1x squared, negative 2x, positive 7.
Good. I like that you put it in descending order. Negative x squared, negative 2x, positive 7. Number 8, Dylan.
Negative 2x, negative 10.
Negative 2x, negative 10. When we add the inverse. Number 10, Joshua.
Positive 12x to the 7th.
Good. Positive 12x to the 7th. Number 12, Lana.
45x to the 4th, y to the 6th.
45, x to the 4th, y to the 6th. Number 14, Adam.
X to the 15th.
X to the 15th. Number 16, Dylan.
Negative 8x to the 3rd, yx to the... No. Negative 8x cubed, y to the 6th.
There we go. Negative 8x cubed, y to the 6th. Number 18, Joshua, you get the big one. What do we got?
X to the 9th, y to the 9th.
Really close. Lana?
Negative x to the 9th, y to the 9th.
Negative x to the 9th, y to the 9th. When we raise those to the power, the first one's going to become a positive x squared, y squared. The next one's going to become a negative x cubed, y cubed. And the next one's going to become a positive x to the 4th, y to the 4th. So now there's only one negative, which is odd, which is negative. Add the exponents of the x's to get x to the 9th. Add the exponents of the y to get y to the 9th as well.
That's just because in the last term I put a negative. I don't
Right, forgot even at power gives you the positive there. Number 20, Adam, when you distribute.
Negative x to the 4th, positive 17x cubed, negative 10x squared.
All right, look at number 20 in your textbook. Ignore what you wrote. Look in your textbook. Let's go through this sign, number, letter. On the first distribution, sign.
Negative.
Number.
8.
Letter.
X to the 4th.
Good. So negative 8x to the 4th should be our first term. Then let's go to the next term, sign.
Positive 14.
Positive. Numbers 14. Letter.
X to the 3rd.
Good. Positive 14x cubed. And then the last sign.
Negative
Negative number,
10,
letter.
x squared.
There we go. So negative 8x to the fourth, positive
Wow.
14x cubed, negative 10x squared should have been our answer. Number 22, Dylan.
3x to the fourth, negative 3x cubed, negative 18x squared.
There we go. 3x to the fourth, negative 3x squared, or cubed, excuse me, negative 18x squared. Let's see, there were 11 of those on there. Anyone go 11 for 11 by any chance? How about 10 for 11? You just missed one? 9 for 11, just missed 2. All right, questions on the 1 or 2 we missed? Going once on questions. Going twice on questions. Going on questions. Page 105. Let's take a look at the word problem that you had for homework. Page 105. Word problem 10. And probably did this in a notebook, though looks like Lana found a way to squeeze that beside the Grand Canyon. It's a good thing the Grand Canyon's so big. Good. Bueno. All right. Let's have Joshua read this for us.
Several members of Bethel Church spent 17 days on a tour of Israel, Egypt, and Germany. They spent twice as long in Israel as in Germany and 3 fewer days in Egypt than in Germany. How many days did they spend in each country?
All right. How many unknowns do we have here, Josh?
3.
And they are?
Israel, Egypt, and Germany.
Now these two are really close together. Germany's going to be a bit more of a out-of-the-way destination, it looks like. But anyway, Israel, Egypt, and Germany. I suppose if you're wanting to learn a lot about the Holy Land, right, spending some time in Egypt would be valuable. Certainly a lot of time in Israel would be valuable. Why Germany? For a church
Probably
tour.
because of the concentration.
I mean, maybe.
Roman Catholic. No. Is that what they are then?
That's where the Reformation started, right? There was a lot in Germany that happened that's got, Christianity breaking free of the Catholic Church. So I suppose there's something to be said for some time in Germany as well. Anyway, which one of these gets to be X? Josh?
Germany.
Yeah, it keeps coming back to Germany, right? Twice as long in Israel as in Germany. 3 days fewer in Egypt than in Germany. So Germany gets to be X. And how would we represent Egypt?
X minus 3.
Yeah, 3 days fewer, so X minus 3. And what about Israel?
2x.
Yes, twice as long in Israel, so 2x. What's your equation?
4x minus 3 equals 17.
Good, because if you take all the time spent in Israel, Egypt, Germany, it should add up to the total time on the tour, which was 17 days. That apparently does not include flight time, or flight time is already factored into these numbers. To solve, obviously, class, we first need to...
Positive 3 on both sides.
Good. Or we said we could move it over as a positive 3. It's the same thing, it's just a little quicker maybe, to get 4x is equal to 20. And then x is going to equal 5. Okay, so that means they spent 5 days class in Germany. How long in Israel? 10 days. How long in Egypt? 2 days. And there's your 17 days. And did it want all of those? Yes. How many days in each country? So there are our answers. Be good to go on all of this. All right, questions on that?
Nope.
All right, go and clear your desk except for a sheet of paper, or maybe 2, and a pencil. And let's go to review for your exam coming up in our very next lesson. That'll be on Monday. Set your books aside. We'll be done with those. I'm going to start with some algebraic representation exercises. Start with some algebraic representation exercises. If you were listening, you would hear me say, clear this except for a sheet of paper. Let's go to review for your exam coming up in our very next lesson.
We have an exam.
Exam Monday. Yes, lesson 43.
How about an exam for next class?
All right, number down if you would, 1 through 12. Number down if you would, 1 through 12. I got 12 algebraic representation questions for you. Somewhat similar to what you will see on your exam on Monday. Number down 1 through 12. And number 1, I simply want you to algebraically represent any number. Algebraically represent any number. Number 2. I want you to algebraically represent the next consecutive number. I want you to algebraically represent the next consecutive number. Number 3. Represent any even number. Represent any even number. Number 4. Represent the next consecutive even number. Number 5. Represent any odd number. Represent any odd number. Told us in college, if you vary your voice, it makes class more interesting. You know, like, it's not more interesting, it's just weird. Yeah, you know, whatever. All right, weird, interesting. All right, number 6, represent the next consecutive odd number. Represent the next consecutive odd number. I don't know why, just because it popped into my head. Number 7, represent the sum of D and M. Represent the sum of D and M. Number 8, if Joshua wanted to buy some footballs for some reason, and the footballs were $22 a piece. Yeah, and he's just like, Mr. Dasky, I know you need some new footballs for PE because eventually we're going to get to do football again. Oh, I miss the good old days. And anyway, I don't know, Scott, if you ever got to, I don't think you're old enough to have gotten to play football. Anyway, we used to do flag football. It was pretty cool. Oh, good old days. I don't know. We used to do it. Once we started combining with the girls, we couldn't do flag football
I
anymore.
know, that'd be weird.
Yeah, it would be. So, yeah. One of these days, when we get a girls' PE teacher, though, that's what we need. We just need somebody to take girls' PE, and guys can do flag football.
I don't know.
They can tackle football.
Basketball.
Oh,
Did
then we
they used to have a football team?
I don't remember.
You
Anyway,
right.
so Josh, back to Josh. Sorry, we got sidetracked. Josh is buying footballs for me. And they're $22 a piece, and he buys F footballs. How much does it cost to buy F footballs if they cost $22 each? That's number 8. Pardon the interruption there. Let's suppose Adam is R years old. Let's suppose I'm twice as old as Adam. How old am I? If Adam is R years old, and I am twice as old as Adam, how old am I?
I have a question. Could I put old?
Oh.
You get it wrong, but you know, whatever. Number 10. My grandpa is 5 times as old as Adam. How old is my grandpa? My grandpa is 5 times as old as Adam. How old is Gramps? I don't call him Gramps.
We'll put super old.
Hey, thinking of you, Grandpa. I don't know if that's quite the way you wanted to be thought
Do you
of.
still have?
I do, actually.
Oh.
I have like 6 grandpas.
I don't have
Number 11. Let's suppose that Dylan and Joshua decide to have a race from one side of the PE field to the other. And let's suppose that Joshua finishes in S seconds. And he beats Dylan by 3 seconds.
Oh,
How long does it take Dylan to run from one side of the field to the other? If he loses to Josh by 3 seconds, Josh finished in S seconds. So Dylan finished 3 seconds.
Dylan would probably win.
I would probably
You
win.
guys have no faith in me.
I've never seen
I
him
have
run.
faith in you.
I don't know these-
Actually, I think you probably
Wait, can you
win.
pull me up? Can you pull me aside?
Number 12.
I mean, I can't run fast.
Can you pull me
Yeah, I
aside?
see you
Number
guys
12.
teach each other that.
Represent 4 more than the product of M and N gives 12. Represent this sentence. 4 less than the product of M and N gives 12. 4 less than the product of M and N gives 12.
You should pull me aside.
Shh.
Study. Shh.
All right, let's see how we did on our answers. Number 1, class, how do we represent any number?
X.
X. How about the next consecutive number, number 2?
X plus 1.
X plus 1. Now technically you could have put any letter for number 1, and you could have put that letter plus 1 for number 2, but X and X plus 1 is easiest. Number 3, how could we represent any even number?
2x.
Plus 2? Oh.
No.
For number 3, I would go 2x, though technically 2x plus 2 is not wrong, if we're going to be technical about things, right, Scott? Scott hates the technicalities. Now, you're going to love geometry class when you get there, Scott, because technicalities, we're all about
Wait, is he
technicalities
still
in
gonna be
geometry.
gone?
Maybe he'll be back by then, you know,
Should be got
next
lost.
year. Who knows?
Come back
Maybe he'll be
by.
back. We'd love to have him back.
Yeah.
But, you know, either way. Number 4, how would we represent the next consecutive even number?
2x
2x plus
4.
2x plus 2, or if you're Lana, 2x plus 4. If you're Lana, bless your heart. We love you, Lana.
Yeah.
Number 5, how would it represent any odd number?
2x plus 1.
2x plus 1. Number 6, how would it represent the next consecutive odd number?
2x plus 3.
2x plus 3. Number 7, how would we represent the sum of D and M?
D plus
M.
D plus M.
Yeah, that's what I wrote.
Number 8, if Joshua buys F footballs, they cost $22 each. How much does it cost to buy the footballs for me?
22.
22F. Number 9, I'm twice as old as Adam. Adam is R years old. How old am I?
2R.
2R. Grandpa is 5 times as old as Adam. How old is Grandpa?
5R.
5R. Number 11, Joshua finishes a race in S seconds. Dylan finishes 3 seconds behind him. How long does it take Dylan?
S minus 3.
S plus 3.
S plus 3. It took him 3
Alright.
more seconds.
I didn't think about that.
Yeah, it takes him 3 more seconds to finish,
I
so
thought
S
it was
plus
just
3.
Was it the only one?
Number 12, how would we represent 4 less than the product of M and N gives 12?
Mn minus 4
minus
equals
4
12.
equals 12.
Mn minus 4 equals 12. Questions on that? Let's take a look at some more review problems. One of the things you're going to see on your exam is order of operations. So at your seats, I've got 4 order of operations problems for you. Go ahead and work those at your seats, and we'll go over all 4 of them together. School colors. Don't say weird colors. Come on now. Okay, it's blue and yellow, not quite blue and gold, but close enough.
It looks green, right?
It looks green.
It looks green. That's green. That's yellow.
It
That-
looks
That's green. That's yellow.
Your shirt is
That's
It's like
blue.
a neon green.
Your shirt is like mint green.
Yeah.
I could make it green, but that's yellow. Anyway, work the problem.
It's kind of a mix.
Bless your heart. Yes, sir.
Are we supposed to solve them?
Yeah. Good.
Oh, I wrote all the problems out.
You don't necessarily have to copy the problems down. That was certainly not a bad idea.
You know, you didn't even really have to put the times.
Okay, now that.
No,
That's
that's
green.
Oh.
That's green. Do you see that?
Mhm.
Green.
And you're gonna change it back.
Yeah.
See? Yellow.
Yeah, yes it is.
Were you just coding?
What?
Were you coding?
You guys could do that on computer.
Just changing font color.
You were like,
Use like PowerPoint.
Oh, no.
You
I was
don't-
using shortcut
You didn't
commands.
really have to
Wow.
put times 4 plus 11 because it's in parentheses.
you should hit Alt F4. Or
Be quiet.
you control shift W.
Let them work. All right, let's go and take a look at these together. And there we go. All right, so on the first one, the first thing we have to do in order of operations class, of course, is parentheses. So 5 minus 1 gives
4.
4 times 4 minus 12 divided by 3.
Or
Yellow. All right, then we can do what, class?
Multiply.
Multiply divided. There's no exponents to worry about, so we can multiply to get
16.
minus,
4.
4.
and then of course we get
12.
12. Easy enough?
Now you're just showing me all the colors.
Questions on that? Oh, you know what's coming next, Lana. All right, next thing we need in this one, parentheses again, but there's 1, 2, 3 things. That's green, in parentheses. So the first thing we need to do in the parentheses class is multiply the 1 times 4 to get.
4.
So we get 6 plus 4 minus 12 divided by 2. That's a 2, just a poorly written one. And then we still need to take care of parentheses, but remember, addition and subtraction, we just go straight across. 6 plus 4 minus 12 equals
Negative 2.
negative 2 divided by 2, which of course is
Negative 1.
negative 1.
Oh, he's doing it.
Once again, we need to start with the parentheses class.
15.
4 plus 11 gives 15, so 7 plus 2 times 15 divided by 5. Once we take care of parentheses.
Oh, that's pretty color.
Multiply, divide. Now here there's a multiplication and a division back to back, so just take them straight in order. 2 times 15
30.
divided by 5.
6.
6. So we get 7 plus 6.
13.
And of course 7 plus 6 is
13.
13.
Oh, I did 15 divided by 5.
Technically, you can get off the hook with that as well, but only because the problem ended there. So as a general rule, I wouldn't do that. All right, coming over here, starting within the parentheses, there's 2 operations. Which one first?
Division.
The division to get
8 minus
3.
3. So it becomes 3 plus 9 times the quantity 8 minus 3. Of course, 8 minus 3 is 5. So we have 3 plus 9 times 5. Then we need to
45.
multiply to get 45, and then 3 plus 45 gives
48.
48. All right, questions on order of
I
operations?
like your colors.
Thank you, I like them too. All right. Do some more practice now with evaluation. It's kind of the same thing, just you have to plug in numbers first.
Still looks a little bit green.
Hush, Lana. I thought it might be a little on the small side, but it is the right size. I do 44 font. It's 44. It just looks kind of small to me.
Maybe it's just your eyes.
Just hoping, making sure it was big enough that Scott could read it. I don't know. I guess if you can't read it, Scott, too late. I mean, I can read it even on a small screen, so I think you can. Right on the edge of the camera, so half of me is over here, and the other half of me is off camera. It's really weird.
Wait.
I'm all off
You
camera.
like turn the camera.
I turn the camera to get the screen. So normally I just get the chalkboard.
Oh, so like you just move.
But he can still hear us?
Oh yeah, yeah, of course.
Oh. Unless he skips.
All right, let's go ahead and take a look at these together now. And we'll just stay with white chalk here. Instead of messing with Lana's mind. First step on an evaluation problem, just plug in the numbers, right? If x is 5, everybody see an x, there's only two places, plug in a 5. Everybody see a y, plug in the -2. Everybody see the z, plug in a -1, right? And then follow order of operations. So there are no real parentheses to have to simplify, right?
Mm-hmm.
But we do have exponents. We need to square the 5 first class to get 25 times -2 minus -1. Then in order of operations, we multiply to get -50 minus -1. Then we do our addition subtraction. Though, do we ever really subtract in algebra?
No.
We add the inverse, so it's really -50 plus +1, or
-49.
-49. How many had -49 for the first one? Okay, only a couple of you questions.
It's just because I think I tried to do adding and subtracting instead
Same,
of
I
multiplying.
think. I got
understood that.
22.
I got 22.
Ah, so, all right, makes sense now?
Mhm.
Look at the next one. Again, we got to raise to the power first. What is -1 to the 5th power?
-1.
So we have 3 times -2 times -1, which gives us,
Negative.
how about +6?
Yeah.
Oh no.
I got that.
Yeah,
Because
I
all the
got that.
signs,
Right.
it's all multiplication, you just take it straight all at once
Yeah,
when it's
so
just
I
all
got
multiplication.
Yeah.
Look at the next one. We need to start with the exponent. Let's cube the -2. So we have 2 times 5 plus 4 times -8 times -1. Here we've got multiplication, here we've got multiplication. Let's multiply 2 times 5 to get 10. Keep this plus, and then let's multiply the 4 times -8 times -1.
-32.
Careful, there's 2 negatives. +32. 10 plus +32 gives 42. Should have been our
I
answer.
got -23.
Let's do one more here. Let's suppose, let's say that L is equal to 4. Let's suppose R is -3. Let's suppose M is -2. And let's evaluate M squared R plus L cubed minus LM. Random 3 letters that popped into my head.
What was that?
My local bottle.
Ball.
Just like that local bottle. I sound like Nick on the Geico commercials. That's old. All right. Let's again, we need to plug in the numbers. -2, we need to square it, times -3, plus we're going to need to cube the 4, minus the 4 times the -2. Pretty straightforward, and let's see, who should we call on for this one? Let's go to Lana. Lana, what do we need to do first?
Oh, we did that wrong. Well,
What should you have done first?
Oh, what happens to the accent?
It disappeared.
You get positive 4.
Times -3, alright.
Plus 64. And then -8.
I suppose we can go ahead and multiply there. For that matter, I guess we could have, once we got the positive 4, we could have multiplied that -3 just to go straight to,
12.
Wait.
Negative 12.
I was calling on Lana, -12.
Yeah.
Right, the -4 times, or positive 4 times the -3. We have an addition, we also have a subtraction, but we're not supposed to subtract. Right. So we really have a -12, a 64, and an 8. And we combine those all together, we end up with what?
60.
60 is correct. How we got 60 on this one?
I got
Question.
So
Negative
4.
I said 4D.
4D,
Probably
alright.
forgot to square the M.
Oh.
I had -12 plus 64 plus 8.
Probably
I think
just
I
did the
did
math
that.
wrong.
Yeah.
I think you
64
combined
plus-
the.
8 is 72, and
Oh,
72
I
minus
put
12.
52 for some reason.
Ah, okay. Alright, questions on this? Let's take a look at some equations next.
Oh.
Whoa.
Variety of different equations,
Oh.
right? Some are pretty basic, normal looking equations, like the
Basic.
first one. At your seats, do the first one.
Basic?
That's pretty basic.
Are we just doing the first one?
Just the first one. Just the first one for now.
You down one.
You can leave your feet up.
Is this almost not hurt?
Depends on how in shape you are.
This doesn't hurt. I can do wall sits for like.
So that means you're in
10
shape.
minutes.
I'm not sure.
No, I can do 10 I can do wall sits for like 10 minutes. With my hands out straight. No, I can't.
Stop driving.
You don't care. Alright, we care about math because we have an exam on Monday.
Yeah.
Alright, did we distribute correctly to get a 3x -12 and a -4x positive 12? Check your distribution. We good on the first step?
No.
Question.
Oh.
I don't know what it is.
Remember, negative times negative gives positive, okay, so be careful with that.
I already messed that up.
Yeah.
Alright, so there's your first step, right? Get rid of parentheses. Second step, combine like terms. So after that, I combined, well, there's nothing on the left to combine, but I can combine here to get a -3x and here to get an 18. Okay, we good to go now on the combination step. What do we do after we've combined like terms on each side?
Get rid of the little x.
Good, and which one's the little one?
The negative 3.
The -3. So I'm going to bring it over here and it's going to become a positive 3x. In addition to the positive 3x we already had. Or you could say add 3x to both sides. Either way works. Here I'm going to get, class,
6x.
6x. And you know what? If I'm bringing the x over here, I'm going to want to get rid of this -12 anyway, right? So I can either put a positive 12 on both sides or move it over as a positive 12 is another way to think of it to get
30.
30. And so we end up with x is equal to
5.
5. How many had 5?
Wait, what?
Questions?
One second.
Questions on that? Again, there's two ways to think of this. Either get rid of something by doing the same thing to both sides, or you could say move it over, and when it changes sides, it changes
I
signs.
totally
Okay? Either way, we can think of that. All right, let's take a look at the next one. This one's really not that bad if it weren't for the decimals, but that's okay because you know how to take care of it. At your seats, do so. Clear the decimals out as you copy it on your paper. Don't copy it the way it's written.
Do we even have to move it in the first one?
Oh, everywhere.
There's no.
There's a 1. A 1 point. right? That first x has a 1 point in front of it. So we move the decimal everywhere. You end up with what, Lana?
100.
100x.
Oh,
That's a lot.
It is.
not really.
Once
Do
you
you
clear the
think
decimal,
all those are easy, bro?
move everything 2 places. Do we get this?
Yep.
All right, continue at your seats. Okay.
Oh.
We should have gotten 100x plus 12 plus 6x equals 67 plus 40x. We combine to get a 106x. That's the only combination we can do. Plus 12 equals 67 plus 40x. The little x is the 40x, so get rid of it. Put a negative 40x on both sides, or move it over as a negative 40x. Whatever way you want to think of it is up to you. That gives you 66x. Since I'm putting the x on this side, I'm going to want to get rid of the plus 12 anyway, right? That's your donuts. That's a stacking ring. So move it to the other side by putting in a negative 12 on both sides, or just move it as a negative 12 to get 55. Get the x by itself by dividing the 66, but you can reduce by 11 to get 5/6. Questions on this? All right, let's take a look at the next one. Now this one you may want to copy down as written to make the next step easier, or make that first step technically easier. So I'm going to go and copy it down as written. And as I do so, I'm thinking, oh, I hate this. But I'm going to feel better in just a moment when I get rid of this. What am I going to do to get rid of it all, class?
Subtract by, or multiply by the
Multiply what?
Everything.
Everything, right? By the LCD. At your seats, do so. Yeah, but then on the previous one, you're like, do I have to do anything with the x? Everything. Yes, of course you do. Do I have to pick up this piece of trash? Pick up everything and throw it in the trash can. Do I have to run this whole lap?
Hope it rains.
I want to play a game.
I want to play paper football.
You multiply everything by an 18, class. Identify 18 as your LCD.
Yep.
Hopefully so. Oh, it's not that bad. But it's a fraction. But yeah, I don't have to do anything with it. Hey, there's a fraction. If I don't have to mess with a fraction, I don't care about fractions. I just want to have to do something with them like that. It's like, ugh, let me get rid of them. I don't want to try to combine all of that. Just knock it out and get something nice and easy like that. Did we end up with 3/5?
No.
Question?
You're just barely short enough to walk underneath that, like that corner point of the flag.
Yeah, that flag I always hit. This flag, just useless.
He's like,
Questions?
I didn't add the numerator.
Did what?
Add the numerator, like for the last one on the 4x over 9.
You kept the
I
4x?
kept, yeah.
Instead of multiplying the 2 by the 4x, you get the 8x.
Yeah.
Okay, alright, questions? You got all the other ones though?
Yes.
Okay. All right, let's take a look at the next one. Absolute value equation. What's the key?
Isolate.
Isolate the absolute value. So I'm going to copy it here on the chalkboard. Isolate the absolute value, and then you're going to take whatever's inside and set it equal to both positive and negative, whatever. At your seats, work. Good.
First I looked at it like, oh, it's a negative, and then I looked back and I was like, oh, you can divide.
All right, that's why you have to isolate the absolute value before you make that no solution determination. If this were still negative, yes, no solution. But it ends up not being negative, doesn't
So
it?
did you put
I
it?
was just
Like, cause I got to negative 20, and then I looked at I didn't see the negative 4, and then I looked and I was like, oh, you can divide that
Yep.
to be a positive. Fuck.
oh yeah, that's why
Yep.
it's a negative.
You don't divide by 4.
Questions on this? No.
Alright.
Questions? Alright, last equation up there. What do we call that thing?
It's a thing.
It's a polynomial.
No, it's an equation.
Some sort of.
It's got lots of letters in it.
A literal equation?
Literal equation. Good, Josh. But a literal equation. I want you to solve for the x. Solve for the x.
What?
When we say solve for the x, that means get the x
By itself.
by itself.
Okay.
What's with the x right now, class?
An
M and
negative
a negative n. The y and z are not with the x, correct? They're on the other side of the equal sign. We don't worry about them. Which of those m or negative n do I need to get rid of first?
Negative.
Because it's
Least
least attached. We're going to get rid of it by moving it over as a
Positive.
positive n. Or you could say add n to both sides, right? Either way, you get yz plus n or n plus yz. But to get rid of the m, I'm going to need to divide it away from both sides. And the whole side gets divided by the m, and there's my answer. X equals yz plus n over m, or n plus yz over m. How many had that answer for the literal equation? Any questions on equations? This is pretty much a rundown of all the different types of equations we had to work in Chapter 2. Questions? Obviously, a big part of the test will be sections 6.1 to 6.4, adding, subtracting, and multiplying polynomials, okay? So that's what the page 199 homework was all about for the most part. So be familiar with that because that hasn't been tested yet. Equations I've tested you on, though you'll see a little of all of that tomorrow. Algebraic representation and stuff like that, review over the beginning parts there. But the heavy emphasis on this test will be that. And of course, word problems. Since we've been doing quite a bit with word problems lately, all the word problems will be similar to the ones we've done in class recently. Any questions at all for the exam on Monday? All right. Well, we will end there then, Scott. Have a wonderful weekend. Trust you'll do well.
There's no home.
And no homework other than be ready for the exam. So whatever work you need to do to get ready, whether that's going back and watching all 43 lessons or all 42 video lessons. Oh, I wouldn't do that either. Ain't nobody got time for that. Or just going back and skimming through the notes, perhaps. Maybe a worthwhile endeavor for you as well. All right. Have a wonderful rest of your day. And when the bell rings, you'll be dismissed.